Good evening and welcome to tonight's video. Tonight we're going to focus on proving triangles. Yesterday you were proving quadrilaterals. Today we're going to work on three-sided shapes and prove some triangles. So just to get us started, we need some background information. So one way that we prove triangles is by side length. And we have three different triangles that we're going to look at. The first one is an equilateral triangle. And if you'll remember, an equilateral triangle has three equal sides. So to prove an equilateral triangle, we need to prove that all three sides are congruent. And if you remember, to prove that sides are congruent, we use our distance formula. If you need to review distance formula, you can go back to the first video from this unit, and that'll be a good review for you. The second kind of triangle that we're going to talk about is an isosceles triangle. That is a triangle that has two congruent sides. So to prove an isosceles triangle, we are going to need to prove that two of these sides are congruent, using the distance formula again. Our last situation is where we have no sides that are congruent. So we would have to have all three sides being different lengths, and we call that a scaling triangle. There's also one other kind of triangle that we're going to look at proving today, and that is proving a right triangle. If you remember, a right angle is an angle that's 90 degrees. So a right triangle is going to be a triangle that has exactly one 90-degree angle. Alright, if you remember, a 90-degree angle is formed by perpendicular lines. So we need to prove that two of the sides of the triangle are perpendicular to each other. And to be perpendicular, they have to have negative reciprocal slopes. That's what we talked about when we were writing equations for parallel and perpendicular lines the other day. So to prove a right triangle, we must prove that two of the sides of the triangle have a negative reciprocal slope. So let's jump into an example. We have triangle ABC, and it has coordinates 2, -3. It has a point at B, which is 5, 4, and a point at C, which is 2, -1. So the first thing that I've done is I've gone ahead and graphed this on my coordinate plane that was provided. I've labeled my vertices as A, B, and C, and I've also gone ahead and put in the ordered pairs. That's going to help me when I come down and make a table, similar to what we did last night, in just a minute. So we're going to look at the same two things for classifying triangles that we did with quadrilaterals. We're going to need to find the length of each side, and we're going to have to find the slope of each side. So I'm going to come down to my chart, and I have the same columns I had yesterday. Notice this time, though, I only have 3 rows because a triangle only has 3 sides. So the first thing I want to do is I want to label what each of these sides are going to be. If I just go around the triangle, I'm going to have side AB, I'm going to have side BC, and then it's going to come back around to CA. And just so I have these to work with when I am doing my calculations, I'm going to go ahead and put in the ordered pairs for these, just like we did yesterday. So I have -2, 3 for point A and 5, 4 for B. I'm going to come down to the next line. I'm going to have 5, 4 and 2, -1. And then I'm going to have 2, -1 and -2, 3. Now, I'm going to do the first example with you guys. I'm going to go ahead and work the distance for side AB. So I'm going to plug in to my distance formula. I'm going to have my x2 minus x1. Remember that two negatives become a positive, and that's going to have to be squared, plus my y2 minus y1 squared. So if I look at this, this is going to be the square root of 7 squared plus 1 squared. 7 squared is going to be 49, and 1 squared is going to be 1. Add those together, we're going to get 50, so I'm going to have the square root of 50. Now, I'm just going to leave it as the square root of 50, because as I simplify the other ones, I'm going to find that I can still compare them even without getting a decimal. For example, I know that the square root of 50 is not going to be equal to the square root of 37. But if I get another square root of 50, I know that that side is going to be the same. Now, if we look at slope, we're going to do our slope formula, y2 minus y1. So 4 minus 3 over 5 minus a negative 2. Alright, 4 minus 3 is going to give us 1. And 5 minus a negative 2 is going to be the same thing as 5 plus 2, which is going to give us 7. Alright. Now, I'm going to let you go ahead and calculate the distance and the slope for the last two sides. And then we'll get back together and check your answers. Go ahead and pause the video now and work those problems out. Alright, so if you did your calculations correctly, for BC you're going to find that you had a side that was the square root of 34, and that CA was going to be the square root of 32. When we come to our slopes, for BC, we had 5, 3, or 5/3, and we had 1 for our slope for CA. Now, thinking about the ways we classify these, we're first going to look at the sides to see how many do we have the same. So we have a square root of 50, a square root of 34, and a square root of 32. Since none of those distances are the same, we are going to say that this is a scalene triangle. Now, if two of these had come out to be the same, we would have said it was isosceles. And if all three of those matched up together, then we are going to say that it is an equilateral triangle. But since all three of these are different, we have to go with scalene. Now, to look for the slope, we're going to tell whether it's a right triangle or not. Remember, to be a right triangle, they have to have sides that are a negative reciprocal slope. Just a reminder of what a negative reciprocal slope is. If, for example, we had one side that was 4/3, to be a negative reciprocal, it would have to be negative 3/4. We flip it and change the sign. So we want to look and see if we have any flipped. One thing that's helpful is if we have any whole numbers, to go ahead and write them as a fraction. So 1 is the same thing as 1 over 1. Now if I look at 1/7, 5/3, and 1 over 1, I don't have any that are flipped. If I did have any that were flipped from each other, then I would want to make sure that one was positive and one was negative. If that was the case, we would say that it is a right triangle. But in this case, since we have 1/7, 5/3, and 1 over 1, we're going to say that this is not a right triangle. As far as our justification goes, for scalene, we knew it was scalene because we had no congruent sides. And we knew it was not a right triangle because we have no opposite reciprocal slopes. All right. If you have any questions, feel free to stop by in the morning and see Ms. Blaylock or I. We'd be glad to help. All right, just a short little addendum to the video. I realized that chart might have been hard to see because it was a little small in the paper. So I just wanted to give you a chance to see what I had in my chart in case you had not known what a number was or had trouble seeing the number. So if you need to double check your chart that we made in the video, you can go ahead and take a look at this little chart here. Thanks.